right, today's lesson and tomorrow's are going to deviate a little bit from the notes in your book. In fact, what I've done is I've kind of done my own notes here a little bit just because I didn't think the notes in the book went into enough depth. Because these two topics of special right triangles, actually it's one topic but two separate triangles, are something that often that students struggle with a little bit, and I want to make sure we spend enough time talking about it. So let's start with our first triangle today. We'll deal with our second triangle tomorrow. You'll get some patterns. Make sure you're taking some notes on this, especially notes regarding the patterns. You probably want to make flashcards of the patterns so that you can work on things, because there's some memorization that's required here. All right, the first special triangle we're going to deal with, the special right triangle, is the isosceles right triangle. Now, isosceles triangle means a couple things. First, it means I have two sides that are exactly the same. So if this side is x, this leg is x, this leg is congruent, it must also be x. It also means if these two sides right here are congruent, that the angles opposite them must also be congruent. That's our old isosceles triangle theorem. So if those two angles have to be congruent, and I've already used up 90 degrees for my right angle, that means I have 90 degrees left. It means each of them must be 45 degrees. So we call this a 45, 45, 90 right triangle in a lot of cases. It's a 45, 45, 90, because that's describing the angles. So the two angles are the same, means the two legs are the same. How long does that third side have to be in terms of x? Well, we can do that using Pythagorean theorem. Okay, I'm just going to call this C for now. And I get x squared plus x squared equals c squared. But x squared plus x squared, that's 2x squared equals c squared. So c equals the square root of 2x squared. But according to my rules of radicals, that's the square root of 2 times the square root of x squared. Square root of x squared is just x. So it's x times the square root of 2. And that's my pattern for the lengths of the sides. The legs are x. The hypotenuse is x times the square root of 2. Now, for those of you who are still struggling with the radicals, you'll note in Chapter 9's resource folder in Schoology, there are a couple podcasts now that just go over how to simplify radicals. So be sure to be looking at Schoology resource folder for Chapter 9 and look at those extra podcasts if you are struggling with how to simplify radicals, because it's going to be pretty important. So there's your pattern. Every 45, 45, 90 triangle fits this pattern. Every one of them does. So since that's the case, let's try to work on our pattern. If this leg is a isosceles right triangle, if this leg is 5, how long does this leg have to be here, n? Well, it has to be 5 also, because they have to be congruent. And the hypotenuse is simply the leg times the square root of 2. Or in this triangle over here, if this leg is 12, then this leg, being congruent, is also 12. And this third side, you got it, 12 times the square root of 2. We aren't going to decimally approximate that. We're going to be exact with our values. So again, memorize the pattern. X, 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 root 2. Okay? That's our pattern. We're going to memorize it. Let's try this one. A little bit tricky, but I think you'll be able to get it. It's n root 2. Well, this side's 10 root 2. So what do these two sides have to be? That's your question. But what if the hypotenuse is a whole number? Oh dear. Now what do we do? Well, we could set up a Pythagorean theorem and solve this pretty easily. Because I know these two legs are congruent. This is a 45, 45, 90 triangle. So I could say that x squared plus x squared equals 8 squared. or 2x squared equals 8 squared. So 2x squared is 64. So x squared is 32. So x equals the square root of 32, which simplifies to square root of 16 times square root of 2, or 4 root 2. So we could do the math. A few steps of work, but we could do the math. And we could find the lengths of those sides. But instead of just finding the sides, we could also learn a second pattern. And sometimes finding a second pattern is really useful. So let's work at this. So n squared plus n squared equals x squared. We know that. So 2n squared equals x squared. Or n root 2 equals x. We already learned that. We did that pattern already. But what if x is my known value? What is n going to equal? Well, what do? N equals x divided by the square root of 2. We have to rationalize that. So that's x root 2 over 2. So if x is the known side, then n is x over 2 times the square root of 2. Or half of the hypotenuse times the square root of 2. There's our second pattern for this triangle. Oops. Don't need that. Never mind. So how does that work? Well, if I've got the whole number for the hypotenuse side, then the legs are both half of that, or 7/2, times the square root of 2. And you'll notice that the 45 and 45, 90 triangle, we always use the square root of 2 in our pattern. Every single time. That's kind of useful. So if I know the hypotenuse, the legs are half the hypotenuse times the square root of 2. Little trickier. What if I do 3 root 5 for this side? Well, our pattern still holds. This time I know a leg. 2 legs are the same. And the hypotenuse is the leg times the square root of 2. So root 5 times root 2 is root 10. And if it's simplified, we'd have to simplify it, but it does not, so I don't have to. This time we know the hypotenuse. So I know the leg is half the hypotenuse divided times the square root of 2. And you're going to have to figure out what that length is for your next question. So again, to summarize, now that everything's done, we have 2 basic patterns for isosceles right triangles. The first one is x, x, x root 2, because we know the length of the leg, and we need to find the length of the hypotenuse, because the legs are the same. The second pattern is where we know the length of the hypotenuse. Then we know that each of these 2 legs is half the hypotenuse times the square root of 2. So those are 2, it's the same pattern, just kind of rearranged. But in one of them, we're given the legs, and we need to find the hypotenuse. In the other one, we're given the hypotenuse, we need to find the legs. Definitely want to have both written down, definitely want to have both memorized. All right, that's the end of today's podcast, and we'll see you in class.